Welcome back, Contemporary Math. We are in chapter 4D now. We are going to finish this off with loan payments, credit cards, and mortgages. So this will be the last chapter. You get a crazy formula in. And then the next section, we will do taxes. So loan basics. First thing that they define is the loan principal. So the loan principal is it's a dynamic sort of number. It's changing as you make payments. So it changes over time. So if we talk about the loan principal, it's the amount of money that you owe at any particular time. The interest that is charged is going to be charged on the loan principal. If you want to pay off a loan, you have to pay down the principal to $0 is what that is saying. Loan term is the time you have to pay back the loan. And so they give you a little scenario like let's imagine we're borrowing $1,000. Our APR is 12 so that we have a 1% AP or monthly percentage rate. We pay $100 towards the principal each month plus interest. So if we do that, we're figuring this out month by month. Month one, we have a principal of $1,000. When we make our payment, our interest on this is going to be 1% of $1,000 or $10. So we're going to take 10% interest. We're going to make a $100 payment towards the principal. So we're paying $110, but we've only knocked off $100 off of this thing. Same approach for the next one. We start off with 900. So we're starting off with the principal that we knocked down our old principal. We're starting with this principal now. So we start with the 900. We do 1% of 900. So we're paying $100 plus the 9% in interest. So the total payment would be $109. So we knock down our principal $100 each time. You might notice our interest payment each time is going to go down a little bit as we knock more off that premium. So as you go further in your loan, your interest will be a little bit less. So if we're looking at this thing, and you pulled out a loan for $1,000, if you want to repay this thing, this is not the way you typically repay things. Typically, our payments are not going down in values. Typically, what we like is for all our payments to be the same. So what we call those things are installment loans or amortized loans. Those are loans where you pay off with equal regular payments. So this is not an amortized loan. So we will do a few examples with amortized loans, but if we want to repay a loan, they give us a loan repayment formula in the book. So all of this, I think, is just reusing variables that we've already had. Our PMT, if we want to know what our payment on our loan is going to be for an installment loan, is our principal times our APR over N. And then I get 1 minus, and then parentheses 1 plus APR to the negative NY. So this is the first time that we've had negative exponents in a formula, but this is a negative exponent up there. So you should be getting a negative exponent. So my payment is the regular payment. So we're going to come up with one number for our payment. We're not coming up with multiple numbers. We're going to have a regular amortized payment. The P is the starting loan or principal. That's the amount that you borrowed. And so this is the principal that we start with. So I said it changes from month to month, but this is the original principal that we're figuring out. My APR is my annual percentage rate, N is the number of payment periods per year. So this changes a little bit with the wording maybe for each formula. We start with the number of compounding periods. We start with the number of payment periods when we start doing payments, right? And then the last thing is Y is the loan terms in years. So these are both time variables, right? But this, you have to pay attention. This is the number of payments per year, and this is the number of years. So we have an example to try out this thing. We got a new toy. Let's try it out. Suppose that you have student loans totaling $25,000 when you graduate from college. That would be nice. The interest rate is 11%. APR, and the loan term is 15 years. What would my payments be? So you want to figure out your payment. And so we're referring back to this formula. So the first thing that I want to put on there is my principal. So I'm doing my principal is 25,000. I want to multiply this by APR. APR. My end is 12 because I'm making payments each month. Okay. Now the bottom is the thing that's a little bit crazy on this, but this looks like 1 minus, and I'm doing 1 plus my APR over N looks like 0.1 over 12. And I'm raising this to be negative. N is 12 and Y is the number of years. And then they close bracket. Okay. So a little bit of order operations here, but we're doing 25. Now we have to divide this first. 0.1. Is giving me 0.009167, somewhere in that ballpark. Does it give me 1 minus? And it's giving me to the minus 12 times 15, which is giving me to the negative 180. So I believe what I did is I divided the 0.11 over 12. I multiplied the negative 12 and the 15 together. Those are things that are in parentheses. Those are sort of things that you should do first. So I'm going to do this all in one swoop. So this is 1 plus 0.009167, 1.009167. And I want to raise that to the negative 180 power. So if I take 1.009167, raise it to the negative 180 power, that's giving me a crazy decimal that looks like 0.193487. I'm multiplying these two, I'm subtracting these two. I'm getting something like 229.1. And on the bottom, I'm getting something like and subtract this from 1. 0.8065. And the final thing I'm doing is dividing these two numbers. And if I divide those two numbers, I've got to round to the nearest point. The amount I'm looking for. So take a step back and see what we answered. We want to figure out what our monthly payment would be, and they give us all this information about the loan in order to pay back $25K in 15 years. We'd have to make payments of $284.15. Okay. 284.15 is what I'm going to put down here. So it's 284.15 minus payment here. How much will you pay over the lifetime of the loan? So we're going to make a payment. We're going to make a payment of, and I want to think about how going to make this payment. So if I'm making this payment monthly and I'm making it for 15 years, 15 years. So I'm making this a total of, I think we did 15 times 12 already, 180. There's a total of 180 payments happening here. And if I do 180 times 284.15, if I multiply these three numbers together, I'm getting 51147. So maybe you see 284.15, you're thinking that's not too bad. But if we look back at this thing, we borrowed 25K. We're paying twice as much as what we borrowed. So what is the total interest that you will pay on a loan? So this is the total that we pay for. This is all the payments that we make. So if we take all the payments that we make, which is 51,147, and I think about how much more this is my loan principal. So if I'm subtracting these two, I should get 26,147. So what this is telling me is that this 26,147 wasn't two things that you pay on a loan. There's principal and interest. Those are the two things that you're paying off. You got to pay the money back that you borrowed, and you got to pay a little bit extra, or a lot extra in this case. But they're definitely going to try to make you pay it. Okay, so example 2, we're going to use this same setup in example 2. But now we're going to put it into a month-by-month table and try to see what's happening with this loan. So if we think about our balance, during month 1, our balance of the loan, make a payment, is going to be that 25K. We're starting off with 25K. Interest on the principal. So if we want to know what our interest is, we're going to have to divide by 12 to get our monthly interest rate. So if I do the 0.11 divided by 12, this is the interest on this 25K. So what I'm doing is taking 11 of the 25,000. And if I do that, whatever, multiply the two things together, you should be getting 249.1. Do they say, okay, our total payment is the thing that we figured out previously. And I just want to like maybe go through this, like our 284.15. Be the same all the way down. So fill this out. Absolutely could. We know that thing has to be the same. So what's happening is we're paying the same amount on our loan, but you might notice these values are going to shift and change around a little bit. And so if we think about this, I want to know what my payment towards the principal is going to be. So if $229 of this is interest, and I made a $284 payment, then what I'm doing is I'm taking the 284 and I'm subtracting the 229.17 to get to 54.98. That's the difference of these two things. So you're taking 54.98 off of your principal. So if your principal starts off at 25K and we take 54.98 off of that thing, what should be here is the 24. Okay. Now we start this process all over again. So now instead of taking what, 25, we're starting with this amount now. So 24,945 and 2 cents. That's the principal on this guy on month 2. So now what we're doing is we're taking 11/12% of the 24,945 right there. But I'm changing the amount that I'm taking the 11/12 percentage of. So if I do 11/12% and I multiply it by what, 24,945.02, I should get 228.66. And now we're back at this problem. If I spent 228 on my interest and I made a payment of 284, how much did I take off of my principal? So what I'm doing is I'm subtracting this from this. Subtracting the 228 from the 284 is going to give me a difference of 55.49. And so I'm making a payment of 55 towards my principal. My principal is the 24,945. I'm taking this amount off of this amount. 24,945.02, and I'm subtracting 55.49. Gives me 24,899.53. And that is my new principal. So my new principal is the thing that I'm starting with now, 24,899.53. I want to do 11/12% of that. So if I'm doing 11/12% of that thing, should give me 228.15. Now I'm thinking, how much did I pay towards the principal? So I got to take my interest off my payment. If I do that, I should get $56. So I'm taking an even $56 off my principal. I'm going to Okay, so now in example 3, they're going to give us 3 different loan options here. So now we're comparing loan options. We need an $8,000 loan to buy a used car. Your bank offers a 3-year loan at 5%, 4-year at 7%, or 5-year at 9%. Calculate your monthly payments and total interest over the loan term with each option. I think I want to change these things around. So I'm going to change this problem a little bit. I think I want to do this 9%. This will make a little more sense. I don't know why I wrote it that way. 5% APR. This would make a little more sense because typically the shorter the loan, the higher the percentage, your APR. And so I want to think about this thing. I want to think about 3-year, 4-year, and 5-year. Is just doing a 3-year loan. So a 3-year loan is at 9% APR. So I think I can fill out all my information. Payment is on top. I want to do my principal, which is $8,000. I want to multiply this by my APR, which is 12. We're going to do monthly payments here. All divided by a crazy denominator that looks like 1 minus 1 plus. My APR over n again. And I'm doing this to the negative ny. So this looks like minus 12 times 3 years for my 3-year loan. And that is closing off the bottom there. So 0.09 over 12 is going to give me 1,000, still 8,000. This is going to give me 0.0075 for the 0.09 over 12. I'm doing 1 minus 1 plus. 1 plus 0.09 over 12. And I'm going to maybe do this quickly. So 1 plus this fraction should be. And I'm doing this to the negative 30 power. I should end up with is something like 60 over minus 36. 1 minus 0.7641. And so I'm taking 60 and dividing it by a crazy small fraction, 0.2358. 2385 ballpark. And when I divide these two things, I should be getting something like 254. 39. If I round it up, it should be 254. So this is my payment on a 3-year loan. So now I want to take this thing and go back and talk about the total payment. What is my total payment that I'm making? So I'm going to make the payment of $254. I'm making it monthly, or a total of 36 different payments. And 1, 5, 8, 6. And so all in all, I'm making $91.58.40 on this thing. So this is my total payment. If I want to know, what is the other question to ask? Monthly payments, total interest over the loan term. So this is my total payment. If I want to know the I look at the 91.58.40 and I think about I had $8,000 in principal that I started with. So what this is going to end up with is $1158.40 in interest. So basically, you're going to pay a little over $1,000 just to take out that money. This is kind of like the cost of your loan when we talk about interest, right? You have to pay back the money you borrowed, plus you're going to have to pay back a little extra. So a 3-year loan is going to cost you $1158. A 4-year loan. So now we want to do this for 4 years. Same process. So you might have to grab some extra paper. I know I did leave a little bit of gap on the top of the next page, but this problem's got a lot of pieces to it. Starting over our process, we want to figure out our payment for our 4-year loan. Our 4-year loan, we have an $8,000 principal. So here, 1 minus plus. So I want to think about, if I go back and look at this equation, like what is going to change? My 8,000 is going to be the same. So instead of 0.09, I think I'm going to have 0.07. It's still going to be over 12. If that's 0.07 over 12, this thing, move my paper up. This thing down here is also 0.07 over 12. This times my y. So my y is different here because I'm talking about the. And so hopefully if I give you the setup and the equation, you can plug things into this equation just like this. This is my principal, my APR, my N, APR over N to the negative NY. All righty then, you got this thing set up. 0.07 over 12. Looks like 0.0058333 repeating. Now I got to do a little bit of cleaning up, a little bit of conduct, order of operations. I'm going to probably just like start doing this step all in one step. So if this is 0.00583, this is 1. I got do this. Okay. So 8,000. What am I doing? 8,000 times what? 0.07012. On the top, we should be getting like 46.67. Is what my top seems to be simplifying out to. On the bottom, I have one minus. Crunch this thing. I don't know how else you're going to crunch it besides a calculator, so you're definitely going to need some sort of technology to get at this, right? So 1.005832 to the minus 48 is going to give me something like 0.75639. And I want to do 1 minus this thing is going to give me or something like 0.2436. Ooh, and I'm doing 46.66667 divided by that answer is going to give me 191.56. If I round it up, 191.57. What I'm getting for this payment. So this is my 4-year payment. I have figured out what my monthly payment is going to be. This is my payment. If I want to know the total payment, I'm figuring 191.57, and I'm going to do that for 12 months for 4 years. I'm doing 191.57 48 times 191.57. I'm doing this 48 times. I should be getting like 91.95. 91.95. So want to know my total interest. Ooh, wrong screen. Sorry. All right, so we have total payment. We want to know what our total interest is. If this is our total payment, what we do is we take the total payment back to my principal of 8,000. So our total interest we're paying for the loan $11.95. I believe that I'm looking for. So it's like this loan is costing us $11.95.36. This one cost us $11.58. So this one I think was actually a little bit cheaper. And now we're going to look at our 5-year loan. And it's the final one we're doing. Whew, we did 2 of them already, so let's do this one a little bit quicker. But we want a 5-year, so let's make sure correctly. So let's set up our payment. Is our principal, which is 8,000. We want to do our APR over N, which is for this one it was not 0.09. We changed it to 0.05 over 12. That like one crazy stuff. Negative 12 times 5 years for this thing. Okay, so if I do 0.05 over 12, and I multiply by 8,000, something like 33.3 remaining on top. If I do 0.05, I divide it by 12, I add it to 1. I do that to the negative 12 times 5, which is 60 power. Then I take 1 and subtract it from that. Something like 0.2207. And now I'm dividing these two things. So I got 33 1/3, and I'm dividing by 0.2207. I should be getting something like 150 and 96.97 cents if I round it up. So I found my payment is 150.97. Now I have to figure out those two other total payment. My total interest. So my total payment is going to be this 150.97. Think about how many times I'm making this. I'm making it monthly for 5 years. So I'm taking this 150.97 and I'm multiplying it by 60 for the total number of payments, and this is going to give me 9058.2. My total interest, what I'm doing is I'm taking 9058.2. Subtracting 8,000 from it is what I'm doing. So I'm subtracting 8,000 from this thing. It's going to give me 1058.2. So this loan is going to cost me 1058.2. Let's see. Let's compare that to the other two. This one's total was 1058.2. This guy was 1195.36. And this guy was 1158. So it looks like the 5-year loan had the lowest amount in interest. It looks like your 3-year loan had the second amount, and it looked like the 4-year loan was the most expensive. So comparing and contrasting these things. With that said, I want to make it maybe clear. That doesn't necessarily mean that like the 3-year loan or the 5-year loan is the best loan, right? And we really got to look at like what our finances is and what we can do. Because we look at this, our payment's going to be $254. If we look at this one, it's $191, right, for the 4-year, versus for the 5-year, our payment was $150. So the 5-year is the lowest payment, and it is the lowest in interest. So it is probably the better loan here, and it is a longer term. So it is probably the best loan here, if I'm being honest. I would probably go with the 5-year loan, but that doesn't necessarily mean that it's the best loan, right? Because it all depends, like kind of how much you could afford. Let's pretend like we didn't have the 5-year option. So if we were stuck between maybe like our 3-year and a 2-year, we get $11.95 versus $11.58. So $11.58 might sound a lot better because it's cheaper, but if we look at our payment's $254 versus our payment being here $191. So this might all depend upon sort of like your personal finances and what you can afford. Like you may not be able to afford that extra. Oh, it's not a whole lot extra on this one, but it is like an extra $15 or something right there, right? Between that 191 and the 254. Sorry, that's not. No, that's quite a bit extra. Sorry. So between 191 and 254, that's more than that. That's what, $60 extra. So it might depend whether you can afford that $60 extra each month, right? On which loan you're going to take. You might have to take the higher price loan because you can't afford the other loan on a monthly basis. So it all like depends upon your monthly finances, right? But having these amounts out there and knowing how much your loan costs, these are all things that are going to help you make an educated like sort of decision on what you should do, right? Hopefully. It's not going to tell you a definitive answer of what to do, but it will give you some information to make a educated sort of decision. Okay, so suppose you have a credit card balance of $1535.43 with an annual interest rate of 23%. You decide to pay off your balance over the next year. What payments would you need to make? Okay, so we want to know the payments we would have to make if we want to pay off this thing in 1 year. So we're going to pay it off in 12 payments in 1 year. We have 1535.43. That is our principal on this balance. 43. Multiplying this by my APR over N. So our annual interest rate is 23. So we're doing 0.23. By 12. On the bottom is the crazy thing. 1 minus, 1 plus. 12 times y, which is 1. Okay, so we have had this set up a few times, but if I divide these two and then I multiply by this thing, I should be getting something like 29.429075. On bottom, so if I look at this thing, I have 1 minus. If I want to do 0.23 over 12 and add 1, and then raise that to the negative 12th power, what I should be getting here is something like 0.79626. I subtract 1 from that thing and I divide it by 29.429075. Divide by that thing. Around 144. Around And if you want to figure out how much you're making on that, you're doing that, what, 144.45 12 times. You should be making around, what, 1,733. You could figure out how much you're paying in interest if you wanted to, right? I want to do that without a decimal. There we go. So I think we're paying around $200 in interest to pay this off within a year. That is a high interest rate, so that might be part of it too. But you're also doing it within a short time period, so it'd be a larger amount. Example 5. Paul has a balance of $18,000 on his credit card, and he just lost his job. I promise I did not write these problems this year. Things change a lot within a year, I guess is what I'm going to say. Paul has a balance of $18,000 on his credit card account and just lost his job. His credit card has an annual percentage rate of 22% compounded daily. Suppose the credit card company allows him to suspend payments until he finds a new job. Wouldn't that be nice? But continues to charge him interest. If it takes him a year to find a new job, how much will he owe when he starts his new job? So they're being a little bit tricky here, I feel like. They're starting you off in a section that's like, here's loan repayments. We're going to do all these loans. We're going to have this variable of a payment in there. But here they say, spend payments. We're not making any payments. So we don't need a formula with payments in it. So this one, I feel like they're being a little bit tricky in this problem. If this is tripping you up a little bit, think about it maybe a little bit more. But we actually don't need something with payments. This is just interest that is being compounded. So we have this as our principal. We have this as our interest rate, and it's compounded daily even. Ooh, that's going to be high. But we can figure it out. Compounded once per year. This is how we find compound interest. So he's not making payments. We can simplify this just a little bit. So looking along here, A equals principal. My principal on this thing is the 18,000. My 1 plus my APR is 0.22% over N, which is 365 days in a year. My N is still 365 days. Now I'm doing this by 1 year, I believe, is what he's doing. So we've done a few problems like this. This is 18,000. I crunch these numbers. This is going to be a really small number, but I can put it on here. 1 point. There will be like 3 zeros and a 6, 0, 2, 7, 4. Somewhere in that ballpark. Try not to round that too much, because we're going to have to raise this to the 365 power. So when you start raising things to really large powers, if you round them here, they're going to get really far off when you start raising them to powers. Okay, so I get something like 18,000. This is like 1.24599, somewhere in that ballpark. And when I multiply these two things together, I should be getting 22,427.89. 22,427.89. So this is what they're going to still end up charging this guy. So we want to know how much will he owe when he starts his new job. So this is going to be his account balance. So he's got 22,427.89. But out of that, the 18,000 was the principal. And so if I'm thinking about it, he's paying $4,427.89 in interest just to keep this amount there that he owes. And so he started out owing 18,000. Now he owes 22,000. That's a total of $4,000 that this thing went up in a year when he didn't pay any interest. Okay. That's them allowing him to suspend payments. Your credit card company may or may not allow you to do that, right? Okay. So we talked about loan repayments, we talked about student loans, we talked about credit cards. And so now we want to move on to home mortgages, or to mortgages in general, I guess. More specifically, there are home mortgages in which you buy a house, right? And so when we talk about a mortgage, or a home mortgage is a loan specifically designed to help you buy a house. They have really low interest rates, and they can charge really low interest rates because they got this little guarantee that if you don't make a payment, they can come take that thing right back, right? So they can foreclose on your home, and they can take it right back if you don't make payments. So they tend to be really lenient on their interest rates because they're like, we got some assurance here, right? Where they have insurance that they're going to get their money one way or another. So low interest rates because the house serves as a payment. Your house serves as payment guarantee for it, right? If you fail to make a payment, they're going to do it through foreclosure. Down payment is typically 10 to 20% of your purchase price. It's paid when you start the loan. The closing costs are fees at the time when you take out the loan. So there are direct fees, which charge a fixed amount, and then there's fees as points. So each point is 1% of the loan. So if they give you points, it's the exact same thing as a percent of the loan. Sometimes they divide it into origination discount points. They're essentially the same thing. So there are essentially two types of mortgages that they talk about in the book. They talk really extensively about the first one, and then they kind of briefly mention the other sort of thing. But the first one is a fixed rate mortgage. So this is ideal. It's a little bit easier to solve. And it's probably what you want if you go pull out a mortgage, depending what the market looks like. This is probably the one you want. But if we're looking at this, you need a home loan of 120K to buy your new home. There are two loan options. There's a 30-year with a 4.8, and there's a 15-year with 4.2. Compare your monthly payments and total loan costs under the two options. Assume the two closing costs are the same in both cases and therefore do not affect your choice. So we're just ignoring closing costs and all those other things. We're just looking at our loan. We're looking at how much it's going to cost us to pay this. So there's a 30-year and there is a 15-year. So the one I want to start off with is I want to talk about my 30-year loan. So I want to do the payment for my 30-year loan is going to be equal to my principal, which is 120K. I want to do APR over N. So convert your APR. On my 30-year loan, it is a 4.8. So make sure you put the right APR there. Over N, which I'm going to make monthly payments. I'm going to do 1 minus 1 plus. This is still my APR over N here. And I'm going to go to the negative N, which is 12, times Y, which here is 30. So I have my formula. I can plug in my variables to my formula. Looking at the problem, this is how I'm going to solve my payment for my 30-year loan. So if I do 0.048, divide that by 12, and then multiply that by 12,000, or 120,000, sorry, I should get a number like 480 on top. Okay, so 0.0, what am I doing? 48 over 12. I'm going to add that to 1. This is going to look like 1 minus. This is going to be 1.004. And I'm going to raise this to the minus 12 by 30 is going to give me minus 360. So I'm taking 1.004. I'm raising that to the negative 360. And I'm subtracting 1 from the answer I just got. So if I do those two steps on the bottom, I'm raising this to an exponent, and then I have to subtract it. So make sure you do this stuff in the right order. 76239 is the number that I'm getting on the bottom. So 480 divided by this thing should give me a payment of $629.60. So this is my monthly payment. If I want to know total, I'm taking $629.60. And I'm multiplying that by the total number of payments I made, which is 30 by 12 or 360. And give me there it is. There's my total payment. So this is the 30-year loan. I'm going to make payments of $629. I'm going to make a total of $226,655, which I'm paying like almost what, $100,000 just in interest on this thing, I think. So you can also figure out how much interest. If you want to figure out the interest, it's this minus the 120K. Okay, so now we want to do the 15-year loan. So 15-year payment, 15-year loan. Whew. The payment is very similar. I'm doing 120K. Now I'm changing my APR rate. Instead of 0.48, it's 0.042. I'm dividing this by 12. I'm doing 1 minus 1 plus. This is to the minus 12 times the number of years here is 15. So I'm hoping if I give you this information, you can get this much set up. So if I do 0.042 and I divide that by 12 and then I multiply that by 120,000, that should give me 420 on top. This is giving me 1 minus 1 plus 0.042 over 12 is 1.0035, and I have to raise this to the negative 180 power. So I'm doing a lot of the same steps over again. I feel like if I just crunch this, we're probably pretty much there. I've got to raise that to the negative 180 power. I have to do 1 minus the thing I just got. I do 420 divided by that thing. So I should be getting a payment of $899.70 is what I'm getting here. And if I'm going to do the total payment, I'm doing $899.70, and I'm doing that 180 times, or 12 by 15. So I'm getting 161,946, 161,946. So we're looking at this total price versus the previous total price. This one is definitely a lot less. This one seems like probably the better loan price-wise, right? If we look at the overall price, this one is definitely better. But if we're looking at the individual payment price, this one is actually a lot less. So this is kind of goes with what is your budget? Can you afford to pay more so that you pay less over the long term, right? In general, that's the way things sort of work. If you're going to pay things in a shorter term, you typically pay more money, but you pay less interest overall, right? If you want a longer term, you're going to pay less money, but you're going to pay more in interest overall. They're just taking more out over time. Payment strategies. And so now they say most of the money from early payments mortgage goes to your interest. So they want to talk about payment strategies. So if you want to pay off a loan, the best sort of strategy to do is paying extra towards your loan in the beginning. So if you pay early off in your loan and you pay off more towards your loan, it will actually lower the overall rate of your loan. So with the strategy and what the book kind of says is the more you pay in the beginning of your loan, the better it is. It's better to pay it in the beginning than it is to pay it later in the loan. And that has to do with the interest and getting the interest down, right? The quicker we get the principal down, the quicker we get our interest down, and it reduces kind of both of those, right? Another strategy to the mortgage options in example 6 would be to take a 30-year loan, but try to pay it off in 15 years by making larger payments than are required. How much would you have to pay each month? How much would the total loan cost be? So what they're trying to get at here is that we have 2 loan options. We have a 15-year and we have a 30-year. But we could have went and we could have took that 30-year and we could have paid it off in 15 years. We could have said, hey, we're going to take this 30-year. And then instead of paying what amount they told us to pay, we overpay the amount, right? Is basically what we're doing. So if we wanted to figure that out, we want to know our payment with the 30-year loan in the previous. So we're still doing a principal of 120K. So our principal is not changing from the previous problem. So I'm thinking about 30 years and 15 is what I'm doing here. Information for my 30-year loan. So from the 30-year loan in the previous page, I believe it had 0.048 interest. I'm still doing it monthly. That's not changing. I'm doing 1 minus 1 plus 0.048 over 12. And this is coming from the previous problem. This is coming from the 30-year loan has the 4.8 APR. And so now I need to do to the negative NY. It looks like negative N. And now this is the thing that's really going to change. So if we look at, this formula, right? We're not changing our principal. We're not changing this. We're not changing any of this. The only thing we're changing is the number of years that we're going to have to pay this thing off. So instead of spending 30 years, let's say we spend 15. So this problem should look very similar. These numbers should work out very similarly. So this top, I believe, is giving me 480 again, if I do that. This bottom is giving me, I'm just going to jump to a little bit. We've done hopefully enough of these examples. If you still have questions over it, come see me. Definitely ask me about the order of operations if you're having troubles with that. But I'm going to jump through these a little bit. I should get something like 0.512548 if I crunch all this stuff on the bottom. And if I do this, I'm getting a payment of $936.50. Okay, so what is that telling me? So previously this thing was what, $629.60? So $936.60, and we're going to do this for 15 years. It's going to give me what, 168, something like that. So you might notice, and you might look at the previous problem. What did I get? The other 15-year loan, right? So this is what happens if we take the 30-year loan and pay it off in 15. Our payments are going to be $936.50. The other 15-year loan, if I look at my payments, I got $899.70. And so you're shopping these loans. These are both for 15 years. And you might be saying $899.70 versus $936. Well, obviously I'm going to go for the $899. But here's the thing. If this is the 30-year loan, the minimum payment, right? The minimum payment for this thing is the $629.60 if we take it out. That's what we found in the previous problem, right? This one versus this one. So this is the payment I need to make if I want to pay it off in 15 years, but this is sort of my minimum payment if I pay it off in 30. So there's this sort of like buffer thing that can happen if you take this loan, right? So you should pay $936 to pay it off in 15, which is a little bit more than this, but like, God forbid, things happen out in the real world. Who knows, maybe a plague or something comes along and you lose your job and you can't afford $930 or you can't afford $899 anymore, right? You can only afford $629. This loan would save your butt in that scenario, right? So if you like end up losing your job and can't afford payments as much, taking the longer loan might be the sort of better option if you don't have the security. Because while we have to pay $936 to pay it off in 15, we won't actually default on the loan if we just make a minimum payment of $629, right? So this adds a little bit of buffer in there is what it does, I think. You got to pay extra for the buffer. About $40, right? Okay. So a lot of these are sitting back comparing total costs, comparing monthly costs, and a lot of it's like I said, it's not a definitive answer. Like which one is the better thing, right? It completely depends upon your finances and what you think you can afford on a month-to-month basis. And there's an issue of like personal budgeting in here, right? So I can't really tell you what you should do, but we can make more educated guesses if we understand what is happening in these loans, what our total loan is, what our monthly payment is. We can make better educated guesses. So that was example, 7 said to do that. So instead of taking 15 years, or instead of taking 30 years to pay off the loan, if we take 15, it's going to cost more. It'll cost more even more than the 15 loan, but we have that little save our butt plan. If things go awry, we don't have to pay the full 800 or whatever, 800 or 900. We could drop it down to 600 if that's a little more comfortable. Great Bank offers 90K 30-year 4.5 fixed rate loan. It should be APR with a closing cost of $750 plus 1 point. Big Bank offers a lower rate of 4.25 on a 30-year loan, but it has a closing cost of $1,000 plus 3 points. And we want to evaluate the two options. Okay, so this again is like one of those problems. It's probably not going to tell you everything, but it will give you some good numbers to talk about how much these things cost. So the first thing is option 1 or the Great Bank, right? I want to talk about option 1. So one of the things I want to talk about when I talk about my options is how much is my payment going to be? So my payment is my principal. My APR over N is 0.045 over my N, which is 12. I'm doing the 1 minus 1 plus crazy thing on the bottom, 1 minus 1 plus. My APR over N. This is to the negative N times Y, which is for 30 years. Okay, so if I divide this and then multiply by 90,000, it should be giving me 337.5 on top. I'm doing 1 minus 1 plus. So I think we've had this number before, but we do 1 minus 1.00375 is that number. And I'm raising this to the minus 360 power. $337.5 over, and when I do crunch this number, I raise this to the power, and then I subtract it from 1. I should be getting something like 740,104. And so my payment on this thing, I think I'm figuring out, is $456.02. I want to figure out my payment, and I want to figure out my closing cost. So I have my payment at $456.02. I want to know closing cost. So the closing cost is $750 plus 1 point. So when they talk about 1 point, what are they talking about? They're talking about 1% is what they're talking about. So if it's 1%, it's 0.01% of, and we're talking about the initial loan value, which is 90K. So if we take this and we move it basically by what, 2 decimal places, 2 zeros, this should give me $900 as my closing cost. So it's saying there's a flat rate of 750 plus 1 point. So I'm doing 750 plus 900 for my closing cost. Here's my closing cost, 750 plus 900 is 1650. So there are payments of 456 with a closing cost of what, 1650. That's almost what, 4 payments there. Okay. So we have another problem. That's the first option. The second option. And so we have already done one option. Should be pretty similar to the way that we did the first option. So we're doing 90K again. Now our APR is a little bit different. Now it's 0.0425. We're dividing that by 12. We're doing 1 minus 1 plus a thing, 0.0425 over 12. And I'm doing this to the negative 12 times my years here is, this is a 30-year loan as well. Oh, this is my payment formula. I forgot about my payment out in there, but this is finding my payment. I'm going to skip a few steps because we've done a few of these, but this is 318.75 is what the number I should get on top. The number I should be getting on the bottom is somewhere around 0.7199. What's it? 389. So I'm dividing these two things. 442.75 should be about where this thing is. And this is my payment. I still need to find closing cost. So my closing cost, this one says $1,000 plus 3 points. So if we're doing 0.03 on what, 90,000, we're doing 3% of 90,000. That should give me 2,700. And so I'm doing what, $1,000 plus this 2,700. So the total closing cost will be what, 3,700. I drew 1,000 flat plus 3 points. I'm adding it back to the 1,000 that they told me in the problem. It's in the words. So this is $1,000 flat. This is the 3 points they're talking about. My total closing cost would be 37. Whew. Okay. So now we want to go back and look at these options. So if I'm looking at these options, option 1 has a payment of $456.20. Closing costs are what? $1,650. The other option, my payment was $40.42.75, and I have closing cost of 37. So which one of these is going to be the better option? How do we want to compare them? So if I'm looking at the payment for $456.20 and I'm doing what, $442.75, I think there is what, $13.45 that we're going to save in each payment. And if we're doing this payment 360 times, I think we're going to end up, is it 360 times? Where am I getting off on this? 442.75, 456. Oh, my 456 is the wrong number. 02, sorry. 456.02 minus 442.75. We should be getting a difference of 13.27. And if we make this, if this is how much more that one payment's going to be, we're going to end up saving that much. So by taking the cheaper payment, we're going to be saving about $4,000. I think this is going to be probably your better option because it does have a little bit higher closing cost, but the difference overall, right? In the long term, the difference makes this one a little bit cheaper in the long term. So this is the cheaper long term, and it is the cheaper directly. So this is probably the better option overall. Okay, with that said, there's one last little thing we're going to talk about real briefly, and then we're going to get out of here. But this is the adjustable rate mortgage. So we did fixed rate mortgages. There's another way to do it. You can have an adjustable rate. And what the adjustable rate means, it's more complicated, and I don't want to talk about it. So it changes with whatever the prevailing rates. So they look at market rates, and they adjust your mortgage rate to the market rate. It is not a constant mortgage rate, right? So we have to, it makes it more complicated, and we're not going to look at them too much. They're probably going to plug it into some computer at some point to figure things out. because this is it's a dynamic number. It's changing, and so it's not easy to figure out formulaically or with a simple formula like we have. I say simple, right? But they're relatively simple, I guess is what I should say, right? These formulas are relatively simple. This would be a lot more complicated, and I'm not trying to get there. So stick around. Go watch 4E next. We're going to talk about taxes, and I will see y'all in class soon.